Today's lesson is lesson 3, and it is multiply and divide monomials. Multiply and divide monomials. So far in this chapter, we've talked about rational numbers and the kinds of numbers that are included with rational numbers. We've talked about powers and exponents and how to write them and how to read them and how to evaluate them. So read, write, evaluate. If you're not sure how to do any of those things, you need to be going back and watching the previous videos on your own time. Today's lesson, it says key concept, product of powers. Product means multiply. Power is what we talked about the other day. All right, power to me is a base and its exponent. It's them together. So we are going to multiply powers together. It says to multiply powers with the same base, we add their exponents. Well, in your notebook, I added number 1, keep the base, because this book doesn't tell you what to do with the base. It doesn't say anything about it. So I add that in. It says to multiply powers with the same base. First step is keep the base. Second step is add the exponents. Add the exponents. Pretty simple, but there's so many rules that are easy to confuse that I want to make sure you're paying attention and understanding. So numerically, we have 2 to the 4th power times 2 cubed, or 2 to the 3rd power. So all we're going to do is my base is 2, and as I say right here, we keep the base, and we add the exponents. 4 and 3. 4 plus 3, 7. So my answer is 2 to the 7th power. Algebraically would be with variables. And with variables, you can see you've got a to the m power times a to the n power. My base in that power is the same. It's a. So I keep the base. And what do we do with the exponents? We add them. M plus n. M plus n. You have to memorize this rule. But I'm also going to show you a way that if you don't memorize it or you forget it, you should be able to figure it out. Monomial. Mono. You should know what mono means. 1. Monomial is a number, a variable, or a product of a number and one or more variables. You can use the laws of exponents to simplify monomials. So a monomial, a number, 7. 2, -3. A variable, x, y, m. Or a product of a number and variables. Product means multiply. We're multiplying a number and one or more variables. My numbers are here, my variables are here. So maybe I have -3m. Maybe I have 2xy. Those are monomials. It's one term. Okay, so now we see we've got the laws of exponents that we just talked about to simplify monomials. My rule is keep the base. When I have powers of the same base, I keep the base. And my second step is I add the exponents. If you don't say that every time to yourself, you're not going to commit it to memory. You're going to have to memorize it again down the line. This is 3 to the 2nd power times 3 to the 4th power. If I break it down, 3 squared is 3 times 3. Times, if I break it down, 3 to the 4th is 3 times 3 times 3 times 3. So if I count these up, I have 1, 2, 3, 4, 5, and 6 repeated factors. 6 factors. I keep the base of 3, and I added my exponents together. 2 plus 4, if I need a better visual, there it is. Notice that the sum of the original exponents is the exponent in the final product. So what are they telling us? They're telling us the original 2 plus 4 is equal to 6. 2 plus 4 equal to 6. Example 1, simplify using the laws of exponents. 5 squared times 5. Well, 5 squared is 5 times 5, all right? And if I multiply that by 5, and I'm going to write these as exponents, using exponents, I have a repeated base of 5. I have a repeated base of 5. That's my base, and my exponent would be 3. So then my question for you would be, when you have a number standing alone like the 5 is, what is the understood exponent of that number? What is the understood exponent of that number? Good, it's 1. So typically in my class, we just add that 1 like this so that we remember it. Otherwise, it's likely that we'll forget it. 5 to the third can also be written as 5 times 5 is 25 times 5 is 125. So 5 cubed is equal to 125. There's my answer. Example 2, very similar, except these are variables instead of exponent, or instead of numbers. C cubed times c to the 5th. Well, if I think about my rule, I see that my two powers have the same base of c. My rule says keep the base, and it says add the exponents. So some teachers ask that you do this. Depends on what your teacher wants. Pay attention to what they're asking, not what I'm telling you to do. I just stretch it out so you can see all ways. Keep the c and add the 3 and 5, and I get c to the 8th. We don't know what c is, so I can't evaluate it any further. I forget my rule, and I'm taking a very important test. Okay, so what do I do when I forget my rule? Well, I know that c cubed is c times c times c, and I know that c to the 5th is c times c times c times c. So I always say in class, when in doubt, break it out. I have 3 c's and then I have 5 c's. Oh yeah, I get it. The rule is to keep the base and add the exponents. Okay? Again, notice that the original exponents add up to the exponent here. That's what we're looking for. That's our rule. Last one like this says negative 3x to the 2nd power times 4x to the 5th power. Negative 3x to the 2nd power times 4x to the 5th power. Well, I see a couple different things here. I see a negative 3, which is a coefficient, not a base. I see a 4, which is a coefficient, not a base. But I also see a power, x squared, and I see a power, x to the 5th power. Those are my identical bases, but with a different exponent. Okay, so what am I going to do? I love to color code, so I'm going to go like this. I'm going to multiply my coefficients. You should know that word. I'm going to multiply my coefficients, and then I'm going to keep my base, and then I'm going to add my exponents. So I've got a couple different things going on here. Okay? So my first step is negative 3 times 4. Well, a negative times a positive is a negative, and 3 times 4 is 12. When I multiply powers with the same base, I keep the base, which is x, and add the exponents. 2 plus 5 is 7. So my answer, negative 12x to the 7th power. Again, if I need to break it out because I'm just not sure, I have to remember that x squared is just x times x, and x to the 5th is just x times x times x times x times x. There's 2, there's 5, oh yeah, it's 7. Notice that the exponents of the original equation, okay, are equal to the end exponent here. All right? Got it? So go ahead, grab your notebook, your workbook, and fill these in as we go. I have 2 powers. I have 9 to the 3rd power and 9 squared. Those are 2 powers. A power is made up of a base and an exponent. When I multiply powers with the same base, I keep the base, which is 9, and I add my exponents. And 3 plus 2 is 5. If I have to prove it or I forget, 9 cubed is 9 times 9 times 9. And 9 squared is 9 times 9. All right, so how many 9s is that? That would be 5. If they want me to evaluate, I would continue and do my 9 times 9 times 9 times 9 times 9. No calculator yet. Now I would use my calculator. 81 times 81 is 6,561 times 9 is 59,049. Exponential form, evaluated form. Next one says a cubed times a squared. I see two powers. A cubed, a squared. I see that I am multiplying them. My rule states that when I am multiplying powers with the same base, I keep that base and I add my exponents. 3 plus 2 is 5. Why do I love this one? You got it, because there's no variable or there's no number to plug in for a, so I'm done right there, a to the 5th. How do I double check myself if I forget my rule? 3 a's and then 2 a's. Well, that adds up to 5 a's. Okay, next one, I think I lost my highlighter on that first one, but let me see. Yep, I sure did. So if you're not a highlighting fan, like some of my students are not, here's my coefficient, here's my coefficient. Okay, here is my power of m to the 1st, here's my power of m to the 5th. I multiply my coefficients, -2 times -8. A negative times a negative is a positive. When I multiply two powers with the same base, I keep the base and add the exponent. What's 1 plus 5? 6. So your answer for that one is 16m to the 6th power. 16m to the 6th power. Moving on, we're looking at quotient, and quotient should scream division to you. Should scream division. You should know that word. Today, continuing this lesson, we're going to continue with dividing the powers. The rule states to divide powers with the same base, subtract their exponents. Again, I don't like that this book doesn't tell you to, number 1, keep the base. I think that's an important step in the process. So keep the base, and step 2, as you have written in your notebook, is subtract the exponents. Okay? So dividing looks like this. We have 3 to the 7th, that power, divided by 3 to the 3rd. I keep the base. 3 stays a 3. What a lot of students like to do is make this a 1. 3 divided by 3 is 1. You can't do that. And I'll show you why in just a minute. So 7 minus 3, notice I'm subtracting top minus bottom. 7 minus 3 is 4. So my answer is 3 to the 4th. Same way over here, algebraically, I have the same base. All I'm going to do is subtract my exponents. Keep the base of a and subtract m minus n. A cannot equal 0 because that will not work. Can't do division by 0. Okay? So let's talk about why this works, or why it looks like what it does. 3 to the 7th power equals 3 times 3 times 3. That's 4, 5, 6, and 7. Divided by 3 to the 3rd. Well, 3 to the 3rd is simply 3 times 3 times 3. 3 divided by 3 is 1. They cancel. 3 divided by 3 is 1. They cancel. 3 divided by 3 is 1. They cancel. How many 3s are left? You got it. 4. Matches up right there. When in doubt, break it out. Don't guess your rules. When in doubt, write it out. Break it out. Show me what it looks like. Okay, and this is what I just talked about on the last screen. It says there is also a law of exponents for dividing powers with the same base. So they have 5 to the 7th power divided by 5 to the 4th power. They have their 7 fives, 1, 2, 3, 4, 5, 6, 7. And they have their 4 fives in the denominator, 1, 2, 3, 4. Notice that they've canceled off 1, 2, 3, 4, and 1, 2, 3, 4. That leaves these 3 on the top, which is my answer. If I just subtract my exponents, 7 minus 4, it's 3. But notice, if you do 5 divided by 5 is 1, it can't be because there is not a 1 here. So be careful of that. That's a common mistake. Notice that the difference means subtract, of the original exponents is the exponent and the final quotient. If I had my highlighter, I would show you 7 minus 4 is 3. Okay, 7 minus 4 is 3. Simplify using the laws of exponents. I have 4 to the 8th, which is a power, and 4 squared, which is a power, and I'm dividing them. I'm dividing powers with the same base. Keep the base, 4. Subtract the exponents, 8 minus 2. Again, some teachers like you to do that. It depends what your teacher asks you to do. That would be 4 to the 6th power. If we go ahead and evaluate that, that's 16, 16, 16. That's 256 times 16, which is 4,096. Exponential form, standard form. You forget your rules. I have 8 4s in the top. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Notice I'm checking. I have 2 4s in the bottom. That leaves me with 6, so I am subtracting. Always check yourself. N to the 9th power divided by n to the 4th power. Okay? I have powers with the same base. My base is n. I keep my n. The rule is, when dividing powers of the same base, keep the base, n, subtract the exponents. 9 minus 4 is 5. Again, I don't know what n is, so I can leave it just like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Cancels, 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 cancels. And you see I have 5 left. A little bit different. Okay, a little bit different. 2 to the 5th times 3 to the 5th times 5 squared divided by 2 squared times 3 to the 4th times 5. First thing I would do is put that 1 right there. Next thing I'm going to do, if I had a highlighter, I would use my highlighter, but I don't have it anymore, so I'm going to circle and group these together. My 2's have the same base. My 3 has the same base. And then I have powers with 5 as the base. If I'm doing it just understanding my rules, this is what it looks like. If I'm doing it the way I know my rules, this is what it looks like. 2 to the 5th divided by 2 squared. I'm dividing powers of the same base. Step 1, keep the base. Step 2, subtract the exponents. 5 minus 2 is 3. 3 to the 5th divided by 3 to the 4th power. Keep the base, subtract the exponents. 5 squared divided by 5 to the 1st. Keep the base, subtract the exponents. There's your answer. If they want us to finish it up and evaluate it, I have 2 times 2 times 2 times 3 times 5. 4 times 6 times 5. 6 times 5 is 30. 4 times 3 is 12, and add your 0. Standard form, exponential form. Not sure of your rules? No problem. 5 2's. 5 threes, 2 fives, divided by 2 twos, 4 threes. Notice how I'm lining them up, and 1 5. Cancels, cancels, cancels. That leaves me with 3 twos. That leaves me with 1 3. And that leaves me with 1 5. Doesn't matter how you do it. Learn your rules, or when in doubt, break it out. Grab your workbook. I'm dividing powers with the same base. I have 5 to the 7th power divided by 5 to the 4th power. My rule when I'm dividing powers is to keep the base, subtract the exponent. 7 minus 4 is 3. And 5 times 5 times 5 is 25 times 5, which is 125. Standard form, exponential form. X to the 10th power divided by x to the 3rd power. I am dividing powers with the same base. I keep the base, subtract the exponents. 10 minus 3 is 7. Nothing more I can do there. I have coefficients. I have 12 and 2 as my coefficient, and I have 2 powers, w to the 5th and w to the first. Okay, this is division. You see a division bar, you need to divide. Okay, so I have 12 divided by 2 is 6. W to the 5th power divided by w to the 1st power. I keep my base, and I subtract my exponents. There's my answer. Next one. I have powers with a base of 3, powers with a base of 5. I'm going to add a 1 there. And powers with a base of 7. My rule when dividing powers with the same base is to keep the base, so I could start like that. And now all I have to do is subtract the exponents. 4 minus 2, 2 minus 1, 5 minus 3. 3 squared is 9 times 5 times 49. That's 45 times 49, which is 2,205. Standard form, exponential form. And I would lose that 1. I would not leave that 1 there. Okay, 2,205. Next one. I have powers with the base of 5, powers with the base of 7, and powers with the base of 8. My rule when I'm dividing powers of the same base is to keep my base and subtract the exponents. 6 minus 4, 2. 4 minus 2, 2. 3 minus 2, 1. I might not leave that 1 there, but it doesn't matter. 5 squared is 25. 7 squared is 49 times 8. Exponential form, 25 times 49, 1,225 times 8, 9,800. Standard form. Exponential form versus standard form. Last one like this. I have a power with the base of a negative 2. I have a power with the base of 3. I need to add an exponent of 1. And I have a power with an exponent of 5. Negative 2, 3, 5. 5 minus 2 is 3. 4 minus 1 is 3. 7 minus 4 is 3. exponential form. Do they want it evaluated? Three times 3 is 9. 5 times 5 times 5. Negative 2 times negative 2 is 4. 4 times negative 2 times 9 times 25 times 5. 4 times negative 2 is negative 8. 9 times 5, it's 45 times 25. Again, I'm not a fan of the calculator. I think that the more you use it, the more mistakes you make. Now I have a negative times a positive, which is a negative. Now I'll use my calculator. 8 times 45 is 360. I have a negative times a positive, so my answer is negative. And my answer should be negative 9,000, standard form. Last example. Last example, Hawaii's total shoreline is about 2 to the 10th power miles long. New Hampshire's shoreline is about 2 to the 7th power miles long. My question says, about how many times longer is Hawaii's shoreline than New Hampshire's shoreline? Well, in order to figure out the number of times longer it is, I need to divide, because that's the opposite operation here. Okay, so I'm going to take my 2 to the 10th. It says how many times longer is Hawaii, so Hawaii comes first. 2 to the 10th divided by 2 to the 7th. I'm dividing powers with the same base. I keep the base and subtract the exponents. 2 to the 3rd power. 2 to the 3rd power. 2 to the 3rd power, exponential form. 2 times 2 times 2, that's 8 times longer. 8 times longer. Today we looked at multiplying powers with the same base, dividing powers with the same base. If you need help, go back and watch the videos again so that you have a better understanding of what you're doing.